In today's journey, we give you an update of what we've been up to and what we plan to do next. The astute will have remembered that the last time we brewed in glass, we had a bit of a trouble reaching a boil with our old vessel. Technically we did, just not for very long. But you know us, always learning from our mistakes. We got a laboratory grade equivalent to a lid, watch glass. It's made out of the same glass as our beakers, so it can take some abuse. But wait, that just got us thinking. We could optimize our system a bit more by using a taller vessel of the same volume, meaning it has a narrower diameter, and therefore less surface area to lose heat during boil. Phil is referring to these methods as the carrots, and he developed the stick. Where the carrots are more passive and intended to save every bit of heat we already generate, the stick is designed to actually create more heat. And by design we mean we shoved a heat probe through a 9-inch false bottom. Hey, nothing but the best for us. Although this power cord could definitely use an improvement. How does this not come standard with the ground? And before you comment on how dirty or dangerous this probe looks, we're working on it. We also have a nuclear option as well. By using a bunch of science and math thingies, we figure that if we use smaller vessel, we'll have enough heat to boil in that. These 2,000 milliliter beakers will also be used for starter experiments as well, in comparison to the Erlenmeyer flasks. But we also got watch glasses in smaller sizes so that we could use them on the Erlenmeyer flasks as well. These will be used to prevent cross-contamination during yeast experiments, without getting in the way of the additional cameras we hope to add soon. We also got a volumetric flask so that we can do experiments such as showing how water changes volume dependent on its temperature. Now all we need is a separation funnel, and then our collection will be complete. And on the electronic side, some people may be sick of hearing about the Brew Pie by now. Well, too bad, because it's really important for our future setups. They do the data logging, and that's important for scientific documentation. That's why, in addition to rebuilding these 2 control boxes, we'll be building an additional 2 so that we can monitor even more things at once, while also keeping at least 1 spare at all times, just in case one goes bad. Because remember, it is always possible to make no mistakes and still lose. That is not a weakness, that is life. But to help limit mistakes in the future, we'll be using a ProtoShield to wire up all of our Arduinos in the future. ProtoShields give a solderable and removable area to work with on your Arduino. That means we can solder in any finalized design for our circuitry, limiting any points of failure in the future. At the same time, it makes removing and replacing Arduinos and other circuitry easier by not needing to remember where exactly all wires go at all times. As you can see here, by soldering our relays directly to the ProtoShield, we now have one less set of wires to worry about going bad or coming loose during operation. But do keep in mind that the 110 voltage from your house mains should never go through the Arduino shield itself, as that is too much voltage for the Arduino. It could damage the board or start a fire. So long as you follow the diagrams and make sure there's no shorts, you should be fine. ProtoShields may be a great way to finalize a project for deployment, but it is important to remember they are for people who have experience soldering. And because we're fixing up the insides, we figure we may as upgrade the outsides as well. We should be able to save a lot of headache and hassle by the excess weight on the sides by using these receptacles instead of long cables that come in from the side. This model has the added benefit of bringing a fuse into the mix as well, which is actually a huge benefit because when we're mixing these unorthodox combinations of appliances, it can be easy to lose track of how many amps you're pulling from a single wall outlet. As for the thermal probes, rewiring them to a 3.5mm TRS audio jack means that removing the thermal probes for cleaning becomes much easier. And because all the thermal probes actually have their individual addresses remembered inside the probe, there's no need to actually label the jacks so long as you don't mix up the probes with other controllers, as the Arduino it's been paired with will remember it, but the other ones won't recognize it. These may seem like creature comforts, but they will be the world of difference in our professional deployment. Well, speaking of professional, here you can see why Phil wants to redo the inside so badly. And even if it's not your first project, it is important to remember that once the prototyping phase is done, it's time to go back over everything you've done and double check it for future issues that could arise, such as strain being put on cables from being pulled on, or screws that can come loose from the box being shooken around. Everything should be solid and firm with no rattling when you shake it. And although it may be tedious and boring, it's better to be safe than sorry. Speaking of which, we felt that our Raspberry Pi was getting a little hot, so we're going to put on a fan just in case. And finally, something that's supposed to be hot. Did you know that a lot of hot sauces are actually fermented? We're going to be finding out more about that in an upcoming video. If you have a recipe you'd like to share, we sure would like to try it. And if you have any suggestions for a video, don't forget to comment below. And for those that stayed to the end, we have a super secret tip on how to save money on Star San. We just so happen to have these 1 milliliter syringes. And then we just so happen to remember that a wine bottle is 750 milliliters, 1/5 of a gallon. So if you do the math after reading the directions on the back of the Star San, you will see that we just made enough sanitizer to do any small task around the brew house. Never forget that proper mixing proportions is what makes your sanitizer work properly. And if you've ever wondered if our table's sanitized, here you can see it being done. Like it is every time before we shoot. And if you're afraid of needles, don't worry, because with this trick, there are none. It's a blunt end.